For today's discussion, I'm going to talk about derivatives of exponential functions. So let us recall exponential function. What is an exponential function? Exponential function is a function that takes the form f of x equals a to the x, where here greater than 0 but not equal to 1. The domain is the set of all real numbers, while the range is the set of positive real numbers. If a happens to be 10, then we have the following function. F of x equals 10 to the x. If a is equal to e, approximately 2.71828, we call this number e, Napierian number or Napierian base. Then the function is f of x equals e to the x. What about the graphs of these functions? No? If you have f of x equals a to the x, and a is between 0 and 1, for instance, the base of the exponential function is 1/2, 1/3, 1/4, 3/5, as long as between 0 and 1. This is how the graph looks like. So that's how the graph looks like, given by the orange. Look at how the graph behaves. It is asymptotic to what? To the x-axis, no? To the positive direction of the x-axis. It intersects the y-axis at 0, 1. And then as it goes to the left, the graph gets higher and higher. Okay? Faster. Gradually going to the left, it goes faster. Okay? So when you say asymptotic to the positive direction of the x-axis, the limit of e to the x as x approaches positive infinity is equal to 0. But remember, a here is what? A number that is between 0 and 1. 1/2, 1/3, 3/5, 2/5, 3/7. So that is interpreted as what? A to the x approaches 0. Okay, the value gets closer and closer to 0. What about limit of a to the x as x approaches negative infinity? As x goes to the left without end, the graph of a to the x, or the value of a to the x, keeps on increasing. Okay, the value of e to the x keeps on increasing. Okay. What about the graph of f of x, which is equal to a to the x, where a is greater than 1? So examples of bases that are greater than 1, we have 2, 4, 5, 10, 5/3, 7/5, 8/7, as long as greater than 1. No? So this is how the graph looks like. This time, it is asymptotic to where? Asymptotic to the negative direction of the x-axis. Okay? It intersects what? The y-axis at 0, 1. Okay, guys? So, and then as x goes to the right, so the graph keeps on growing. In terms of limits, limit of a to the x as x approaches positive infinity, we have positive infinity. Okay, that is, it keeps on growing as x goes to the right. As x goes to the left, that is, as x approaches negative infinity, a to the x, what, guys? Goes to 0. Okay, so again, take note that a here is greater than 1. What about the definition of the number e? The number e can be defined as a number such that it satisfies this relation, okay? Limit of e to the h minus 1 all over h as h approaches 0 is equal to 1, okay? If this limit is true, then E here is what? Is what we mean in this discussion, okay? And that is approximately 2.71828, this base, so that this limit as h approaches 0 will become 1. We can also define E as this limit expression. E is equal to the limit of 1 plus h raised to 1 over h as h approaches 0, or limit of 1 plus 1 over h raised to h as h approaches what? Plus or minus infinity. Okay? For the derivatives of exponential functions, let u equals f of x be a differentiable function. Then, for a greater than 0 but not equal to 1, the derivative with respect to x of a to the u is given by a to the u, ln a, derivative of u with respect to x. We copy the exponential function, then we multiply it with the ln of the base, and then multiply this product by what? By the derivative of the exponent of this exponential function, okay? Now, if a happens to be e, so, or that is approximately 2.71828, the derivative with respect to x of e to the u is equal to e to the u times the derivative of the exponent. So that is the derivative of u with respect to x. Take note that I did not write anymore ln e because ln e is equal to 1. Okay? So that's why there is no ln here in this derivative. Okay? Is that clear, guys? So let us have the following examples. Number 1. Let's say we're given f of x is equal to 3 raised to x squared. What is the derivative of this function? F prime is equal to, so this takes the form of a to the u. So our u here is what? X squared, right? So again, our u is x squared. What about our a? Our a is 3. Okay? So the derivative of a to the u is a to the u. So we copy the function 3 to the x squared. Multiply it with ln of the base. So ln 3. Okay? And then times the derivative of what? Derivative with respect to x of the exponent. What is the exponent? X squared. So what's the derivative of x squared? So that is 2x, right? So we multiply it by 2, then x, okay? Then what is our base? 3, no? Times 3 to the x squared ln 3. Okay, guys? So that's it. So that's the derivative of 3 raised to x squared. What about number 2? G of x is equal to 4 raised to 5 x cubed minus 3 x to the fifth. What about this one? So this time, our base is 4, and the exponent is 5x cubed minus 3x to the fifth. So this exponent is our u, and our a is 4. So what is g prime of x? So that is equal to 4 raised to 5x cubed minus 3x to the fifth. Then we multiply it by ln 4. That is ln of the base. And this is what? Multiplied by the derivative with respect to x of the exponent. So what is the exponent? 5x cubed minus 3x to the fifth. Okay? So what's the derivative, guys? So the derivative is 15, x squared. 15 x squared, then minus, for the second term here, 15 x to the fourth. Okay? So then times the remaining factors. So we have 4 raised to 5x cubed minus 3x to the fifth ln 4. Okay, guys? So that's the derivative. If you want, you can express it in factored form. This part, you can still factor this because let's say it's a multiple choice. So alternatively, if this is not found from the choices, it might be in this form, 15 x squared multiplied by, what's the other factor here? 1, no? Minus x squared. Okay? Then multiplied by 4 raised to 5x cubed minus 3x to the fifth, then times ln 4. Okay? That's it. Although 1 minus x can still be factored, but I think this is enough. Okay? Any question, guys? What about number 3? Y is equal to 3/5 raised to the square root of 4 minus 3x squared. Our base here is what? 3/5. Exponent square root of 4 minus 3x squared. What's the derivative? Since it takes the exponential form a to the u, so the derivative is a to the u, so 3/5 raised to square root of 4 minus 3x squared. And then we multiply it with the ln of the base. So ln of 3 over 5. And then this product is multiplied by the derivative of the exponent. What's the derivative of the exponent? The exponent is what? 4 minus 3x squared, then take the square root of this. Na? What's the derivative of that radical, guys? Guys, what's the derivative? We have derivative of inside negative 6x, right? Over 2 square root of 4 minus 3x squared, okay? And then multiplied by 3 over 5 raised to 4 minus 3x squared ln 3 over 5. Okay? Can we still simplify this, guys? Yes, no? So this one is negative 3. Okay? So negative 3 multiplied by x over the square root of 4 minus 3x squared, and then times 3 over 5 raised to square root of 4 minus 3x squared. Then everything is multiplied by ln of 3 over 5. Okay? So this is the derivative of y. Any question with that, guys? Okay, what about number 4? H of x is equal to 5 over 2 raised to x plus 1 all over x squared plus 4. Okay, so here, what is our base? 5 over 2. What's the exponent? X plus 1 all over x squared plus 4. So let's separate that exponent. So let u be equal to x plus 1 all over x squared plus 4. Because we are going to take the derivative of this later. So let's take the derivative now, okay? Or let's take first the derivative. And then just plug in this derivative that we're going to have later, okay? What's the derivative of this exponent, guys? This is quotient, right? So how do we differentiate quotient? The denominator, derivative of the numerator, minus the numerator, derivative of the denominator, all over the square of the denominator. Okay? Let's simplify this, guys. So this is equal to what? Our u prime, no? So that's our u prime. Get it, guys? What is our u prime in simplified form? Or what is the derivative of this in simplest form? What's this derivative? So we have x squared plus 4 minus 2x squared minus 2x. Okay? All over x squared plus 4 raised to 2. Now, x squared minus 2x squared is negative x squared, no? So we have negative x squared minus 2x plus 4 all over x squared plus 4 raised to 2. Okay? Am I right, guys? So let's now differentiate h. What's the derivative of h? So we copy the exponential function. Okay? Hence, the derivative of h, so that is h prime of x, is equal to, so what is h prime? That is 5 over 2 raised to x plus 1 all over x squared plus 4 multiplied by ln of the base. The base is 5 over 2, right? And then times the derivative with respect to x of x plus 1 all over x squared plus 4. We obtained already the derivative of this quotient, no? So what's the derivative? We have negative x squared minus 2x plus 4. Am I right? What about the denominator? We have x squared plus 4 raised to 2. And then this is multiplied by what, guys? 5 over 2 raised to x plus 1 all over x squared plus 4. And then everything multiplied by ln of 5 over 2. So this is the derivative of h. Any question here, guys? Guys, any question? Okay. So let's have number 5. Y is equal to 7 raised to 4 cosine x. So this time, we have a exponential function whose exponent is what? Trigonometric, no? Involving trigonometric. So we have 4 cosine x as the exponent. So you must be familiar with the derivative of trigonometric. So what's the derivative? Copy the exponential function, multiply it by ln of the base, so ln 7, and then this product is multiplied by the derivative with respect to x of what? The exponent. Okay, guys? So, but what is the derivative of 4 cosine x? Negative sign, okay? So again, what's the derivative of 4 cosine x? Negative sine x, and this is multiplied by 4, no? Okay? So 7 raised to 4 cosine x ln 7, and this is multiplied by negative 4 sine x. Derivative of cosine x is negative sine x times 4. Okay? So let's write it in a nicer form. Negative 4, then times 7 raised to 4 cosine x, then ln 7 times what? Times sine x. Take note that sine x is not multiplied to 7, huh? But to ln of 7 or to this whole product. Okay? So that's it. Okay, guys? Number 6. So if f of x is equal to 10 over 7 raised to tangent squared 3x. So what about this? So f prime of x is equal to, copy the exponential function, then multiplied by ln of the base, then times the derivative with respect to x of tangent squared 3x. What's the derivative of tangent squared 3x? This is considered general power, no? Remember, guys? Power formula. But our base is tangent of 3x. So 10 over 7 raised to tangent squared of 3x, ln of 10 over 7, then times, what's the derivative? That is considered general power. Drop the exponent, copy the base. The base is tangent for this case. And then what's the derivative of the base, which is derivative of the tangent? Secant squared 3x. Okay? So if you watch the video about differentiation of trigonometric functions, you should know how to differentiate tangent squared 3x. Okay, guys? So that's it, no? So let's just rewrite it in this form. 2. Then we have tangent. I think better to start with these functions. Then multiplied by 10 over 7 raised to tangent of 3x, and this is squared, no? ln of 10 over 7. Okay? So that is our derivative of f. Any question with that, guys? What about if I have g of x is equal to cosine of 2 to the x minus 1 minus cosecant of 2 to the x minus 1. This is not exponential, but trigonometric, no? Differentiation of trigonometric functions. The functions involve cosine and cosecant. But notice inside cosine, cos and cosecant exponential functions. Okay? So what's the derivative of cosine, guys? Negative sine. Copy the argument. So 2 to the x minus 1. Multiply it to the derivative of what? Of its argument. Okay? Same thing here. So what's the derivative of cosecant? Negative. So this negative, so positive now. And that is cosecant of 2 to the x minus 1 cotangent of 2 to the x minus 1, but it is multiplied by what, guys? Times, I will put the operator here, times the derivative with respect to x of same expression or function, 2 to the x minus 1 also. Okay, so that is equal to negative. What's the derivative of 2 to the x minus 1, guys? What's the derivative of that, guys? So that is 2 to the x ln 2. But what's the derivative of x? 1. Then derivative of negative 1, 0. Okay? So plus, so copy cosecant of 2 to the x minus 1 cotangent of 2 to the x minus 1 times, what's the derivative? So we got that already actually, no? So 2 to the x ln 2. Okay? We can factor out the common, no? Common is 2 to the x ln 2. So times negative sine x of 2 to the x minus 1 plus cosecant of 2 to the x minus 1 cotangent 2 to the x minus 1. Let's start here. Cosecant of 2 to the x minus 1 cotangent of 2 to the x minus 1, then minus sine of 2 to the x minus 1. Okay, guys? That's it. So that's the g prime of x. I enclose this so that it will not confuse with ln of 2 of this, no? ln of 2 together with this, so that I have only ln 2 really. No? Any question, guys? Number 8. What if our base this time is e? E raised to 4 minus 5x to the 6. So here our base is e and our exponent, which is our u, 4 minus 5x to the 6. Okay? So what is the derivative, guys? What is f prime of x? So that is copy and then multiply it by what? By the derivative of the exponent. And this is equal to e raised to 4 minus 5x to the 6. What's the derivative? 0. And this is negative 30 x to the 5th, right? Or that is negative 30 x to the 5th e to the 4 minus 5 x to the 6. See, this is our f prime of x. Any question with this, guys? No more ln of the base because ln e is 1. We don't need to write that. Okay? Let's say I have e raised to square root of x plus 3. So what is g prime of x? Copy the exponential function. Then multiply it by the derivative with respect to x of its exponent. So we have e raised to square root of x plus 3. What's the derivative of this radical? So that is the derivative of inside. All over 2 square root of x plus 3. Okay? Get it, guys? What about the derivative of the numerator here? Yeah. This, what is about this derivative? So derivative of square root of x, that is 1 over 2 square root of x. That's the derivative of square root of x. Derivative of 3, 0, no? Okay? All over 2 square root of x plus 3. Let's simplify. So we multiply both the numerator and denominator of this by 2x square root. 2 square root of x over 2 square root of x. So getting what, guys? We're just simplifying, no? Actually, that's already the derivative. So this is now 1, right? And in the denominator, we have 4 square root times square root. So we just have square root of, so x times this, no? Okay? So plus 3 inside. Square root of x plus 3, then that is multiplied by x inside. Okay? Or finally, if you want it to write in a much better form, so we have 4 square root of, let's and 4 square root of x times square root of x plus 3. So this is the inside. That's the denominator. The numerator is e raised to square root of x plus 3. Okay, guys? That's it. So that's the derivative. What about if we have y is equal to e raised to one over cotangent x. The exponent of e is 1 over cotangent x. So our u here is 1 over cotangent x. Okay? What's the derivative? E raised to 1 over cotangent x times the derivative with respect to x of 1 over cotangent x. So we have e raised to 1 over cotangent x. What's the derivative, guys? So that is negative. If you have constant over function, negative derivative of this denominator, negative cosecant squared x. Okay? All over the square of that denominator. So negative, negative, positive now. And then multiply this e raised to 1 over cotangent x over cotangent squared x. So finally we have e to the 1 over cotangent x times cosecant squared x all over cotangent squared x. Any question with this, guys? Children? Okay, you don't have questions? Number 11. Let's say if I have y equals e to the x plus e to the sine x all over e to the x minus e to the sine x. So this is not directly exponential, no? You can't apply directly derivatives of exponential functions formulas here, no? So we consider this as what, guys? Quotient for the meantime. So how do we differentiate quotient? The denominator derivative of the numerator. I'll do it mentally. What is the derivative of e to the x? E to the x. Derivative of x1 plus what is the derivative of e to the sine x? E to the sine x. Derivative of sine x, cosine x. Okay, guys? Then minus, I don't think it will fit here. No? So let me transfer this on the other slide. So copy the numerator, then derivative of the denominator. What's the derivative of the denominator? Guys, e to the x, then minus e to the sine x then derivative of sine x, cosine x, no? Okay, guys? All over e to the x minus e to the sine x. Get it, children? Quantity is squared. Okay, let's simplify the numerator first. No? So if we distribute this, we have e to the what, guys? What do you think, guys? E to the 2x, right? Then plus e to the x plus sine x. Remember, same base, we add exponents, no? Then multiplied by cosine x. Minus e to the x plus sine x, right? We add exponents. Then plus or minus? Minus, I think. Minus e to the 2 sine x. Sine x plus sine x, 2 sine x. No? Cosine x here. Okay? What about the expansion of this second term in the numerator? Minus e to the 2x. Okay? And then negative, negative, positive. E to the x plus sine x. Then times cosine x, right? What about this? E to the x times e to the sine x, but negative, no? E to the x plus sine x. And then for the last term in the numerator, is it the last term? Negative, no? Negative, but negative, positive. So again, this is negative, negative, positive. E to the what? 2 sine x. And this exponential function is multiplied by cosine x. Okay? So copy the denominator. Okay? What are the things that we can eliminate, guys? Let's use other color. These terms are eliminated. What else? Guys, these terms no, are also eliminated, right? Are there still things that we can eliminate? No more. Okay? This e to the x plus sine x multiplied by cosine x added to this, so times 2. Okay, guys? E to the x plus sine x, and this exponential is multiplied by cosine x times 2 now because of this, no? This and this. What about these terms? Times 2 also, right? Minus 2 e to the x plus sine x. Get it, guys? All over e to the x minus e to the sine x raised to 2. Okay? Any question with that, guys? I think we can still write it in a more compact form by factoring out 2 in the numerator together with e to the what? X plus sine x, right? So what is left in the first term? Just cosine x. What about in the second term? Minus 1. Okay, guys? Guys, get it? All over e to the x minus e to the sine x raised to 2. Oh, that's it. So that's the derivative. Any question with that, guys? Number 12. We have y is equal to tangent of e to the sine x minus e to the tangent of sine x. What about this? So this is a mix of exponential functions and trigonometric functions, no? What is y prime? For the first one, differentiating trigonometry. What's the derivative of tangent? Secant squared. Then we copy the base, no? I mean its argument. But we multiply it to the derivative of its argument. What's the derivative of its argument? E to the sine x. Derivative of sine x, cosine x. What about the second term? That is exponential considered e to the tangent of sine x. But what's the derivative of its exponent? That is secant squared of sine x. Okay? But there is still derivative for sine x times, this is multiplied not to the sine x, but to the secant squared, no? So let's put that there. Cosine what? X. Okay? Get it, guys? So cosine of x. Let's arrange terms and factors for each term. So we have e to the sine x times cosine x times secant squared of e to the sine x. For the second term, we have e to the tangent of sine x, then times cosine x, secant squared of sine x. Okay, guys? I think we can factor common. What is common here? Only cosine, no? Guys? If we factor out cosine, we have here e to the sine x. Oh, it looks like 5. And then, what about here? Secant squared of e to the sine x. Then minus e to the tangent of sine x times secant squared of sine x. Okay, guys? That's it. That's y prime.